Welcome everyone to QTE Manufacturing Solutions CircleMill Toolpath webinar. I'll be your host today. My name is Reese Gibson. I want to talk a little bit about QTE. QTE has been in business for over 25 years, providing software solutions and training. They also offer on-site manufacturing process improvement, meaning we'll come on site and work with your employees with your parts on your machines. I also do Mastercam Resller installation services, meaning we will come upgrade and install your software for you. We offer contract services as well, modeling of parts, jigs, fixtures, etc. Also content management solutions. We also offer shop floor integration with DNC and MDC software and implementation for that. Today's agenda be the CircleMill. CircleMill is also an alternative to hole making using end mills instead of drilling, offering a circular motion cleaning out the holes. This has been a technique popular for a long time. CircleMill makes it very easy to do this as well. We're going to talk about start hole. Start hole's been around for a while as well. Basically, if you do not like to helix into the cut, start hole will administer a drill, assigning a drill to it, look at a toolpath operation, and drill a hole wherever the tool plunges. Auto drill. Let's put some of that 2D geometry to work. Very popular if that's what you're working with, 2D geometry. Now the Helix Bore is like a Threadmill look-alike. Basically it does a corkscrew into the circle, to the cut, but it does not clean out the center. Now slot mill, that toolpath is designed specifically for machining slots. And thread milling. We'll talk about thread milling. If you have large diameter threads to interpolate on your CNC mill, and it does not require a lot of horsepower. And also we're going to learn how to create a custom tool for milling operations. Okay, without further ado, let's get started. Now here I have a plate, different diameters, different depths, some blind holes, some stepped holes. It is a solid model at this point, but you can use points, you can use edge curves, and you can use 2D arcs. Okay. Now you really don't even have to have any geometry at all. This example here is if I go to the toolpaths and I go down to CircleMill. This drop down box right here, see my arrow? You can use a pattern. Geometry doesn't have to exist at all. This would be how many holes you want in the X dimension and the Y dimension, and here's where it wants the lower left location. I could snap it to here, I could snap it to the center, or I could type in the dimension. Okay? You can type in as many of these as you want. If you want, by clicking here, you're saying you want 10 in the X. Okay? A grid pattern type. This will work with drilling or circle milling. Okay? Now I'm just going to click somewhere arbitrarily to create my points and hit my green check. Okay? Go pick a cutter. Now since there's no geometry there, it just has a location, I have to fill out every parameter, meaning what's the hole size? 750, 875, whatever the print requires. Now you can rough it out. Now if you use roughing, it'll use a corkscrew type spiral motion, starts from the center and climb mills to the edge of the hole. Okay, this is your step over. 25% of the tool, 50% of the tool, this is your choice, depending on material and the machine tool. Now finishing, I want to do one finish pass at 5 thousandths on the last pass. And by the way, at the last feed rate, I want to go at 5 inches a minute, and I want to raise my RPM to a certain RPM. Now that will override the original one back in this area here. Okay. Now transitions, how do you enter the cut? Meaning start from the center. You want to start perpendicular. Start from the center. My favorite is start from the center. Okay. Depth of cuts are possible. Now linking parameters, how deep you like the hole to go. So really no geometry was even needed, and it does a grid pattern. Okay. Now we'll look closely at the toolpath itself. So it does a corkscrew in, cleaning it out with a spiral motion, arcs in and arcs out. Now if I want to use a solid edge, I can go back to my tool paths, my circle paths, and I'm going to use the sketch mode right here. It defaults the sketch mode. All I have to do is walk over to my solid edge down here and see how it finds the center of the hole down there. Left click one time. Find your solid edge. Make sure it finds the center. See how my auto cursor is snapping to the center and you click. Find your solid edge. Now on your sorting, make sure you don't filter out duplicates, because if you pick a hole over top of the other one, it'll sort it out and will not use it. Okay? And we can walk over to this edge, and we can walk over to this edge. Done. I grab my 5/16 flat or a bigger cutter. We can go get a 1/2 inch end mill. Okay. We're going to rough it. Transition stuck. Now my linking parameters, I want to go incremental, because I picked the bottom edge of the solid model there. So it's going to pick up the depth for me, meaning varying the depth for me for each hole. So one operation can do multiple depths, multiple size holes. Now if you look at the toolpath, it does a corkscrew, and it adjusts its depth, its roughing based upon the hole size, if you notice that. And we'll get rid of this one here. Like I say, depth of cuts are possible. That was picking the solid edges through the sketch mode. Okay. Now some people don't like the helix, so we can go back into here, and on the roughing we take the helical entry off. So now we'll just plunge in the center. Now if I want to drill a hole there, this is where the start hole function comes in. Start hole will look at another operation, at any operation, whether it's 2D pocketing, 3D milling, any operation where the tool plunged, it will go drill a hole there. It's looking at a toolpath operation. Additional diameter mount can be added on to the tool that was being used in the operation you want to use a start hole on. Okay. By clicking the green check, it sticks it ahead of the toolpath that you looked at. Now it will go drill a hole. Now the toolpath will enter from that point, picking up the depth as well. Now, if you're a big fan of 2D geometry, okay, 2D geometry, I don't have the solids package. I don't like solids. I want to use 2D, which is fine. Okay. I'll turn the solid off. Now I just have 2D arcs. Now if you're going to use 2D arcs, you use the same toolpath, only the selection process is a little bit different. Circle Toolpaths, CircleMill. I want to use entities. See the entities? It's looking for arcs. When you pick the entity, you just pick the arc. Now it's picking up diameter and depth. Arcs have to be in the 3D space that they are in print. Same practice. Linking parameters will be incremental, won't they, from the depth. And I'll pick a different cutter just to, this one 5/16 flat there. Okay. Same principle, only using circles, geometry. Now I'd like to talk about the auto drill function. Auto drill uses 2D geometry, location and size. If you notice, there's no depth to it, no solid. AutoCAD files are great for this. What we can do here is go teach Mastercam the arc size and location, and auto drill will automatically pull that drill size from the library for you. Okay? It also does some other nice features in here. Let's go take a look at this function. I'm going to use the mask on arc function. The mask on arc function will teach me the size arc. Mastercam, the software, the size arc. It says, what arcs do you want me to consider? I hit my Control A button and press my Enter key. Okay. And we're not done. We can go grab the red arc as well. So we go mask on arc. And it says, go, okay, what arcs do you want to look at? And I'm going to go, let's go look at the red arc right here. And it says, what arcs do you want me to look at? I hit my Control A button again and hit the Enter key. Now by hitting my green check, it says, what would you like for these holes to be done? Ream them, boring, drilling. We're going to stay with the simple drill. Okay. Do you want to chamfer with the spot drill? Yes. What size of chamfer would you like on the rim of the hole? 30 thousandths. Since we know the diameter, it knows the diameter of each, it'll adjust the Z depth based upon the hole size. Okay. Also, you want to use tip comp? Definitely. Let's break through about 10 thousandths. Now, the depth, I can go absolute. I can go incremental from wherever the arc was picked. Or I can go from the top of the arc down, or from the bottom of the arc, drill to the bottom arc. Now, so if my arcs were drawn in the 3D space, where if the holes varied, I would use bottom of the arc and pick my lower arc to the depth of the hole. But right now, I'm just going to go absolute and type in a -1 inch, because that's my plate. Okay. By hitting the green check, it generates my drilling. It pulls a 5/16 drill and a 1/2 inch drill out and a 3/4 spot drill. Okay. Now by verifying, if you notice, it adjusts the chamfer size, the Z depth on my chamfer size. Okay. But it looked like to me it's jumping all over the place. So we can go, remember, once we create these geometry, we can go back in here and pick on my geometry button and reclaim to resort my holes. Okay, and we regen. And now we'll verify. So now I will move from hole to hole in a more efficient manner. So auto drill basically goes in and pulls the correct tool. You can select more than one arc in one sitting, and the spot drill will go in and change the different depths on locations. So you can mask on arc as many arcs as you'd like. Now let's move on to the Helix Bore, and let's do some thread milling. Now the Helix Bore is basically designed the same as a CircleMill, only it does not clean out material in the center of the hole. Basically it does a helix motion through the arc you pick. Now I'm a big entities fan, so I'm going to grab entities, and I'm going to either grab the bottom arc on the floor or the solid edge. I'm going to grab that arc right there. Using entities, I have to have an arc. If I went sketch, I'd grab the solid edge of the floor. Now by clicking this arc right here, it told me location, diameter, and depth. Now, like I say, the Helix Bore, I could go get I'm going to get like a 1-inch end mill, because remember, this won't clean out the center of the hole. I have to have something, otherwise it'll leave a stem sticking in the center. Okay, there's not much to it. Cutter comp can be applied with wear, and we're going to talk about the perpendicular entry too as well. Okay, now the rough pitch is per revolution. We can do some rough passes, but it's not like the CircleMill where it starts in the center and corkscrews out. Okay, feed rate at the final depth. And also the finish pass will basically feed up through the hole. Okay, I'm going to leave that off for now. Now, since I grabbed the bottom of the hole, I'm going to stay incremental from the bottom edge that I clicked. Okay. So basically, Helix Bore starts from the center, does a corkscrew action. This is popular with face mills. Through holes. Okay. And if you're going to use cutter comp, and you post this out, most machines do not accept cutter comp on an arc move. Okay, so we're going to go look at the code. It's picking up this is a common tech call we get a lot. Now to alleviate this, we go back into our parameters and we do a perpendicular entry. By perpendicular entry, it adds that little line right there that picks up the cutter comp now. Okay. So now I wrap it off center, pick cutter comp up, now do my arc. Most machines need a single line to pick up their cutter comp, and once they're in there, then you can do your Geo3s, and basically it can cancel on the same way out. Now if I do a finish, this will step up. So now when it does the finish, it's dragging the tool up. Now the next toolpath feature I'd like to talk about is the slot mill. The slot mill toolpath is designed specifically for slots, meaning I have to have complete circles on the ends of a long holes. Okay? Slot geometry is only accepted. Now I'm going to use my construction plane. I'm going to go down here and pick my lower rail down here. Pick me an appropriate tool. Cut parameters, I can enter perpendicular or use my swing arc in. Roughing, the plunge angle will be, this is the angle it zigzags back and forth. It's in degrees. Do you want a finish pass? Yes, and leave me 5 thousandths, one last finish path. Do you like depth of cuts? Yes, every 100 thousandths. Keep the tool down. Now my linking parameters, since I picked the lower rail, I can either type in a negative 50 here to go 50 deeper than the lower rail I chained, or I can leave this as a 0 and use my breakthrough. Your choice. Now top of stock is not going to be the top of the part. It's going to be down at that shelf down there, because I don't really want to cut a bunch of dead air. So by clicking my top of stock, I swing my model around, and I like to click on a line leading to that floor. Now between slots I want to wrap it absolute incremental up so I don't scrape my part across the top of the tool. The tool across the top of the part. Now we'll look at this. So it adjusts its step over, so it ramps in back and forth, which is nice. So what I like about the slot mill is no matter what tool you pick, it adjusts the step over. Okay? It's a percentage of the cutter. It just takes more passes. Now moving on to the thread milling toolpath. Thread milling operation is taking a single tooth or multi-tooth paddle type tool and doing helical interpolation with the machine tool on a mill, creating threads. Very popular if you have large diameter holes that have coarse threads. Tapping is not an option here. We thread mill, and people are using the thread milling for multiple sizes. You can adjust the hole size based upon cutter comp. Okay. Toolpaths, thread mill. Now there's two ways we can do this. You can go pick the center of the hole like we've been doing in the CircleMill, or you can use entities and pick the major diameter of the hole. Now I'm an entities person, so either way will work. If you use the sketch mode and you pick the center of the hole, it gets location, but it doesn't get diameter. You have to type in the diameter inside the toolpath parameters. If I use entities, I pick my circle here, it says that's the major diameter and location. See? Okay. Mastercam does not have a thread milling tool library. Most people will just go grab a flat end mill the size of their thread mill tool. Okay, right now I'm going to use a 3/4 flat or a tap. Okay. You can use an existing tool or a different tool. Okay. Now what it wants to know is how many active teeth are on the thread mill itself, because it'll calculate how many laps it has to do in the z-axis. If the full depth of the length that you pick equals how many teeth you have, and the pitch, it does the math and says we only need to make one lap. If it has one tooth, it'll thread mill completely up the whole time. Okay, so if you say it has 5 teeth or 10 teeth, and you tell me the pitch, now the pitch is 1 divided by threads per inch. So you can take your 1 divided by 14, we'll make a 14 pitch thread, hit your enter key. Every revolution it does, it raises the Z up 70 thousandths 1/10, 71 thousandths and 4/10. Okay. Now, multi-passes can be done. I mean, you can rough it. It's kind of like the CircleMill. Lead in, lead out. Would you like a perpendicular entry? Picking up cutter comp again. And the last one here, which says how deep do you want to go? You want to go absolute or incremental from the arc that you picked. Well, I want to go absolute, and I want to go right click, and let's go get a Z coordinate of a point. And I go click the bottom. Okay. So the tool comes in, makes one lap in the Z-axis. And it's only doing it once because it knows it has all the teeth are going to hit it. It doesn't need to make more than one lap as you look at the helix in there. So it arcs in and arcs out. It says this is nice. We'll look at the top view here. So it arcs in, does one complete lap, raising the Z the whole time, cancels comp. Now, if you're wanting to use a custom tool to show actual thread milling, okay, we can do that. Actually, any custom tool can be brought in. There are a few rules, though. When I went to do the thread mill and to select a tool, you can go to the library, or you can right-click here in the white and say create a new tool. Okay? It's a custom tool. See the undefined? Okay. Now, is it a custom file? Or is it on a custom level? Meaning in the same file. Now let's talk about this. If you use a custom file and it's an external file, it's looking for a Mastercam file. If the software gets updated or moved, or this file moves to another computer, the custom tool file is still left on the old hard drive or the old location. If you use it on a custom level, meaning you import the tool into the same file, put it on its own level. This is what I recommend. So let's still do that. We'll learn two things here. We're going to go to File, and we're going to go to Merge. Okay, I'm going to merge in a Threadmill, 14th pitch Threadmill with a 3/4 diameter. Okay, it brings it in. Now the rules of custom cutters are it has to be a closed loop, no center line though. Okay. Now to continue on with the thread mill, we're going to do an OD thread mill, meaning a stem sticking up and thread the outside diameter. Okay, as again, when we go to the Threadmill Toolpath, now if it's an ID or an OD, basically I'm an entities type person, and I click entities and I'd click the minor diameter, which would be the inner circle. That would be the outside diameter or the major diameter. This is a stem sticking up, a bolt. Okay. Again, custom cutter. I'm going to create a new tool. It's an undefined tool. It's a custom file this time. Okay. Where's this custom file at? I have it on my desktop in the webinar. Okay, we look for all files. If it's an older file, simple Threadmill. Now, I'm not importing it in as mentioned in the earlier lesson. Okay, I'm just using it. Okay, 0.750. Okay, calculate speed and feed. Need some kind of feed rate, or Mastercam will not like it. It'll warn you of a incorrect feed rate. Like that. Now, how many teeth does it have? We'll say it has 7 teeth. What's the thread pitch? It's a 14 pitch. 1 divided by 14. Hit the enter key. This is where we say it's an OD thread. See right here? You want to cut from bottom to top, top to bottom. Linking parameters, I believe we're going to go down to a negative 900 thousandths because the stem is sticking up 1 inch. Okay. So now if I run both toolpaths, using the dynamic core, if I do not have enough flute length, it will let me know. The holder drug, didn't it? That's it. I don't have enough flute length. So verify will let you know if it strips the top threads off. Also, if you get the wrong pitch. Okay. If you tell it the wrong pitch, we're going to do this on purpose. Verify. Cross threads it, double threads it. So if a verify does not look correct, you probably have some parameters that are not correct. Using a dynamic cord to bring the stem in, and thread milling the OD. So it'd be 1 divided by 14. Regen. Play both movies. Now you notice that it overlapped twice. So it knows how many teeth you have, and if it can't get it in one shot, it'll make 2 passes. Overlaps 2 teeth. Now we are conventional milling, which people probably do not like. That's an easy fix. It's a right hand. We want to go from top to bottom. So we want to climb mill. Everybody has their way of doing it. So now it's going to drop down, overlap its teeth, come in. If this is a tapered pipe tap, the taper angle right here. This is a decimal of degree, 1.79. The taper is usually 1 degree, 47 minutes, and 24 seconds, which is you have to type in a decimal of degree, which comes out to 1.79. That's what this angle wants. Makes like a tornado. Thank you for watching. Hope this was very good, informative information. Call QTE for any help you need. Thank you for attending.